Hello, this is Shaun Thomas, and today I'm going to go over the AI Homework 8 and talk about my takeaways and show the code running. So essentially, this is a Colab notebook, and what it does is it allows us to write Python code in cells so that we can run individual pieces and parts and modify them as needed. So this first part right here essentially connects to my Google Drive so that I can pull files from my Google Drive and have that saved in the notebook. Um, So now my drive is connected. And then here we copy the data set from inside my drive. This confusion matrix, pretty print.py, and iris data set. So this now saves it locally into the Colab's local file storage um, over here. And then I'm not sure why this is here, but we, I guess, connect to the Google Drive again for some reason. Um, Here we are going to import all the Python packages that we need. And then also the confusion matrix preprint this function from that file that we just got from my Google Drive. And then Colab will automatically download all of that. Colab will automatically download all of that um, behind the scenes, so we don't have to run terminal commands or anything. Um, and then here we have this data frame from the iris data set, which we created right here. And then this describe method essentially just shows what's inside of it. Here we can essentially describe if we want to get only non-numeric features, and I believe there's also a way to get only numeric features, but that's not in here. And this shows only the class label as well. So if I uh, comp those out, that shows that. And then I'll just here we have a preprocessor um, from the label encoder that we pull from our imports, and essentially just preprocesses all the string data into integers so that our models can actually work with the data, because models aren't able to work with strings. They have to work with the integers, and then we print that out with the describe function. Here we do that again. Here we can I guess modify what we want to keep by having the greater than or equal to 2. And again, we just describe that, and then we keep how many we want in the head. Here we randomize the data that we're putting inside of our data frame. And this is because we don't want to have the same data all the time. For a good model, you don't want to have data be repeated. You want random data so the model cannot memorize or overfit on the data. And this gets saved into a CSC, which is the iris randomized data set, which would be right here. That gets saved into here. And then here we have functions that we're going to use later on. And essentially what these functions do is they create a new data frame from our previous data frame that we have. And it takes specifically the features that we want to have inside of it so that we only have features we want the model to look at, so that the model isn't evaluating all the features that could cause noise or skew the results in ways that we don't want. And then here we're creating a new feature based on the length and width called the area of the sepal. And then here we have the same function, or I guess different function, but same concept, where we're creating a new data frame purely with the iris label. And that's just from the class. So yeah, I guess it's just has the names of the 3 irises. I guess I need to run that. Here we have the training and validation split. Essentially what this is it gives us the split that we want for training the model, and then the resulting split to be the validation for the model. So that our model can train on unique data and then validate on unique data that it hasn't seen before. And then we have the num-CV folds, which is the amount of folds we want to use for our cross-validation. And this essentially just changes up the percentage of the not percentage, but the actual data that's getting split by the percentages, so that the 80% and 20% will be different 5 different times, so we can train the model 5 different times without having to memorize data. Essentially what we're doing here is we're taking the data frame and getting our training and validation using the splits, I believe. So we have the total examples and then get a percent of that, and then we will get our validation by getting rid of that and um, having only what's left over. And then I guess it's pretty much the same for these as well. Um, we have all of our features in here and all the targets, I guess. And then we have a data frame purely from the training for the features and targets, and then our validation from the targets and features as well. And here we can just print that into our tables, or I guess data frames. And then we use display here so that we can see all of them, because in Colab you can only, if you print, you can only see the last one. So that pretty much shows all the values, and I guess that's I guess this would be the training, and this would be the validation. Yeah, it says it right here. So this is for the features, and this is for the labels. Um, and then here we can create the scalar by using the standard scalar from preprocessing, and then we can normalize the training and validation so we can get more accurate data. And then we get that in here. And then after that, we have our machine learning models. Here we have a list of just the model names that we're going to use. Currently, there's only 2 inside of the lecture videos. And then here we can start training the models based on our data sets. And here we have the logistic regression model. So yeah, it uses this thing. Yeah, and then it uses multinomial. I'm not sure what that means, but that's the logistic model. And then here we have the support vector classification, and that's what you call it right here. And then here we fit it with the support vector classification. So I believe it's just this line that's different for these two. I'm gonna run that. And then here we can use our validation splits to make predictions on our model that we just trained. As you can see here, the logistic regression is pretty much perfect, I think. Yeah, it looks to be perfect. And then the support vector classifier, looks like it's perfect as well. And that's to be expected on smaller data sets. And then here we can generate the confusion matrices. And then I believe here we're just printing out the stats, their prediction accuracy, and then results overall. Yeah, as you can see here, we have perfect accuracy. Again, that's to be expected on a smaller data set. Looks like we have perfect accuracy here. And then 90% of our fivefold, I guess. So that's to be expected, but with a larger data set and more complicated data set, you wouldn't expect to see perfect accuracy. Not too sure why this is not 100%. Maybe this only shows one of the 5 folds, I guess. I don't know, but anyways, here we can print the confusion matrices. We can actually see them. and then just shows the uh, predicted versus the actual for both of the models. So that's pretty much all the code running and working and all the takeaways that I had from AI homework 8.